factor the quadratic expression x squared plus 2x minus 3. Let's start by writing out our quadratic expression. We have x squared plus 2x minus 3. To factor this expression, we need to find two numbers that multiply to give us the constant term, which is negative 3, and add up to give us the coefficient of x, which is 2. Let's look at the general form of a quadratic expression to understand this better. In our case, a is 1, b is 2, and c is minus 3. We're looking for two numbers that multiply to give us c, which is minus 3, and add up to give us b, which is 2. Let's think about the factors of negative 3. The factors of negative 3 are 1 and minus 3, as well as minus 1 and 3. We need the pair that adds up to 2. We can see that 3 and minus 1 add up to 2. So these are the numbers we're looking for. Now that we have our numbers, we can rewrite our quadratic expression as a product of two binomials. We'll have x plus 3 times x minus 1. Let's verify that this factored form is correct by multiplying it out. First, we multiply x by x to get x squared. Then we multiply x by minus 1 to get x. Next, we multiply 3 by x to get 3x. Finally, we multiply 3 by minus 1 to get minus 3. Now let's combine like terms. We have x squared, and x plus 3x gives us 2x. And finally, we have minus 3. This matches our original expression exactly. To visualize this factoring process, let's look at a graph of our quadratic function. Here's the graph of y equals x squared plus 2x minus 3. The x-intercepts of this graph are the roots of our quadratic equation. We can see that the graph crosses the x-axis at x equals minus 3 and x equals 1. These are the solutions to our quadratic equation when it's set equal to 0, and they correspond to the factors we found. In conclusion, we've factored the quadratic expression x squared plus 2x minus 3 into the product x plus 3 times x minus 1. We did this by finding two numbers that multiply to give us the constant term and add up to give us the coefficient of x. We then verified our answer by multiplying out the factored form and by looking at the graph of the function.